In mathematics, a straight line represents a constant rate of change. Think about a Bota rider traveling at a steady speed from Kampala to Jinja. This chart plots the rider's distance over time. If they maintain exactly the same speed, mapping their continuous journey creates a perfectly straight line on our graph. Two physical traits define this line. The steepness, or gradient, tells us how fast they are going. We call this m. And the point where the line crosses the vertical axis shows us their starting point, the y-intercept, which we call c. To find the rider's position at any point, represented by y, we start with their initial location, c, and add the progress they've made. That progress is their constant speed, m, multiplied by the time they've been traveling, x. This gives us the formula y equals mx plus c. By identifying the gradient and the starting point, we can precisely map out and calculate any location along that journey. This is a graph showing a line passing through coordinates a at 2, 3 and b at 4, 7. To find the exact steepness of this line, we calculate the gradient, which is the ratio of vertical change compared to horizontal change. We use the rule rise over run. By finding the vertical rise first and dividing it by the horizontal run, we avoid mixing up our coordinates. Subtracting our y values gives us a rise of 7 minus 3. Subtracting our x values gives us a run of 4 minus 2. That simplifies to 4 divided by 2, resulting in a gradient of 2. A gradient of 2 means that for every single unit you move to the right, the path must rise by exactly 2 units. Now we need to find the full equation of a completely new line. This time, we only know that its gradient is 3, and it passes through the point 1, 5. In any coordinate pair, the first number is always our x value, and the second is our y value. We take those specific numbers and substitute them into our foundation equation. 5 replaces y, 3 replaces and 1 replaces x. Pause the video right here and try to mathematically isolate c on your own. Multiplying 3 and 1 gives us 3. To isolate c, we subtract 3 from both sides, leaving us with 5 minus 3. Our y-intercept is 2. Finally, we replace m and c in our original formula to write the specific rule for this line, y equals 3x plus 2. Discovering the entire equation of a line always follows this sequence. You combine the known rate of change with a single precise anchor point. Final challenge. Determine the equation of a line with a gradient of 2 passing through point 0, 4. Since x is 0, it sits on the y-axis, making 4 our y-intercept. We instantly construct the final equation, y equals 2x plus 4. This table summarizes the 3 key components. The gradient, m, is the steepness, change in y over change in x. The intercept, c, is your starting point, where x equals 0. And y equals mx plus c is the rule tying them together. Understanding the gradient and intercept allows us to describe constant processes with a single, clear rule. Thank you for watching. Be sure to check out more mathematics lessons and test your skills with the practice exercises on our channel.